So a couple examples of this, and we're pretty close to being done. Pretty much almost all the time when I'm writing it out, and most math teachers never write out mean value theorem, it's always going to be MVT. So just know that's what it means. I'll probably put that on your test too. So, apply the mean value theorem to, starting off with a very easy function, f of x equals negative x squared plus 4 on closed interval, negative 1 to 4. Now again, I look at this, what kind of function is that? Okay, it's parabola, and even in more general terms, it's a polynomial. Because it's just terms being combined together through addition and subtraction. I know it's continuous because it's a polynomial. I can take the derivative, which I went ahead and did real quick, f prime of x equals negative 2x. So therefore, it is differentiable on the whole thing. So I know the mean value theorem applies. It's just like Rolle's theorem. You got to kind of check that, because it's not going to work on all. Sometimes you might not be able to take the derivative. And that'd be a case where if you see division, you know that certain things are going to be excluded from your domain. To finish it, I'm going to set what we found the derivative equal to the average slope part. Okay? So if you look back at the mean value theorem, it said that f prime of x, or f prime of c, was equal to f of b minus f of a all over b minus a. So I just looked up there at the interval that we had. I assigned the negative 1 as a, I assigned the 4 as b, and I'm just going to plug in. And I'm going to plug into the original function, because it says f of 4, not f prime of 4. So we're going to plug in, we're going to get our values. Pretty easy mathematics. We're going to get negative 15 for our numerator, 5 for our denominator. Finish solving by dividing, and we come up with our c value being 3 halves. Plug in 4. Okay, you see it? So c is 3 halves. And again, c would be our critical value. Next one. F of x equals x to the 2/3 on the closed interval, again, negative 1 to 2. So we're looking at the same things. First of all, take the derivative. It is continuous, because if you look at the curve, it's not going to have anything bad. Take the derivative. I'm just going to use power rule. We get f prime of x equals 2/3 x to the negative 1/3 power. And then what I went ahead and did there was just rewrite it without a negative x on it. Now what makes this different from the last one we looked at now? It's a fraction. So is it continuous everywhere on the derivative? What's excluded from the domain of the derivative? So this rule does not apply. It's not differentiable at x equals 0. You plug that in, you get division by 0. So it's excluded from the domain. Therefore, the mean value theorem does not apply. You cannot use it. Okay? So make sure you're looking for that. That's always the first thing you want to check, because you don't want to plug that in and try to do all the work, and then, hey, this isn't working out. Well, it's probably because it can't work out. Okay? The things to look for there, just like you always know, negatives inside of even roots, division by anything that has a variable in it, see what we want. All right, this, we're not really going to use it a whole lot. There are some problems in which this is useful. It's called the alternative form of the mean value theorem. You could get to this on your own pretty easily. All it is a rearranged version of it. So it gives you a way, if you know everything on the right side, to find a point. And again, it's something that you could derive really easily on your own. All it is the mean value theorem, but a little algebra has been done to rearrange it so that f of b is by itself now. You can all see how they got that. but there might be a problem or two, which that is going to save you a little bit of time if you just use that off the bat. Again, you could use it by yourself or figure it out on your own. All right, last example. This you don't have to write down, but I'll just read through it real fast. We got just look over here so that we All right. So we got a fairly straightforward example. We kind of follow what's going on. At some point, let's call this point A. I see the first cop. I keep driving, and then over here, point B, I see the other cop. The distance from A to B is how many miles? 6 miles. And how much time passed? Okay. So 6 miles in 5 minutes. Now, did either cop actually clock me at going over the speed limit? Because what is the speed limit on Highway 61? 65. Okay, so they both clocked me going 65 miles per hour. Why are we going to be able to show that they were able to give me a ticket? How do they know for sure that I was going over that at some point?
Because you only 55.
Okay, the time has something to do with it. So here's a little bit of work with it. T equals 0, PC, so police car 1. We got our distance. First thing I thought about was right here. Our speed is in miles per hour, so our time needs to be in hours as well. So 5 minutes out of 60 hour, 5 minutes out of 60 minutes per hour gives you 1/12 of an hour. So what we're using is, again, the idea of the mean value theorem, that at some point in time, the average velocity is going to have to equal the instantaneous velocity, which is what will get you a ticket. So if you plug this in, you're going to get 6 miles in 1/12 of an hour, because that's how far we went. In that amount of time, you divide, and you come up with 72 miles per hour. So what that is, we just did some math to show that's their average speed. Well, from this point to this point, you were going 65 miles per hour at the end points. If the average speed was 72, what has to be true? Yeah. At some point, like you saw the first cop, you probably slowed down 65. You got a little past him. You sped up, probably way above 72. You had the next cop to slow way down. So if they use the mean value theorem and we're timing you, they could definitely give you a ticket. Which I know they have like the helicopter things. Like if you see those white blocks on the highway, that's what those are. And basically they actually use this. They'll count, okay, well, they don't care about your speed, but they care about, well, this is how long it took them to go from here to here. Do a little bit of math, and like, well, they have to be going at least this fast, so they can legally give you a ticket for that. They don't actually have to clock you if they do it that way. So that's how that works. And again, just the main idea is that the average velocity has got to equal the actual one at some point. So at some point, you were going 72 miles per hour. So that's over the speed limit, so they can give you a ticket. And that does it. So it sounds like you all are getting that pretty well. So that's good. Assignment, I didn't take too long. You got 1 through 15 odds, 19, 27 to 31, and 37 is by itself. That is what I want you to have completed for next time.